All right, part 2 is where we do the examples. All right, find the slope between each of the following pairs of points. So we have point 3,5 and point -1,7. I put that on Sketchpad, 3,5 and -1,7. And just kind of like in the distance thing, we're concerned about the vertical space between those points and the horizontal space between those points, kind of along the streets of the graph paper. This one, just looking at the graph paper, you can see pretty quickly that that's 2 and that's 4. Now here, I'm not asked to find the distance. So I'm not asked to find 2 squared plus 4 squared and find the square root. I'm asked to find the slope. The slope here is rise divided by run. So the rise here is 2, and the run is 4. I'm going to write that over here on this other page. Do I have the right tool here? I think I do. All right, so come on, where are you, mouse? Oh, I'm not connected. How come that's not? Oh, I know why. That was funny. All right, so the rise was 2, and the run was 4, if you look back at that picture. Or if you looked at the 2 points and you kind of looked at that little triangle that they make, just like we use for distance formula, but here I don't use them for distance. I could use them for distance. I'd use the same ones. I'd go 2 squared plus 4 squared equals and square root and all that stuff. A squared plus b squared equals c squared. But for slope, what I want is rise over run, and I should probably reduce that fraction so I don't get laughed at math parties. Anyway, that should be 1 over q. Now, how could I have found this 2 and this 4 quickly without drawing a picture? Well, it's actually kind of tricky. We can talk about that in class, but for now I'm going to say let's make a picture. All right, so the next one, I'll set it up. All right, it says 9, -2, and 9, 5. I know it says C and D, but it's the same slope. The slope here is interesting because it's going straight downhill. Over there a second ago, oh, can I move this? Oh, I can. A second ago was over here. This slope, oh, I can even do this. Oh, you're going to be so impressed. Check it out. I can actually tell it to tell me what the slope was. Remember we just said it was negative? Oh, I'm so glad I did that. I noticed I made a mistake. What's the slope over here? I said it was half. Oh, but wait, it's going downhill, so guess what? I should put a big fat negative out front. Oh, I made my first mistake on video. Don't tell anyone. Okay, back to this. So let's go back. Can I redo? That would be lovely. I can't. I gotta move these back just a second. All right, the slope here, when it's 9, -2, and 9, 5, notice how it says undefined. This isn't an uphill or downhill slope. This is a vertical slope. You can't drive your car or ride your bike straight or up or down the wall. So, yeah, like, is this an uphill or a downhill left to right? It really doesn't make any sense. If we try to divide this, the rise is 7, but the run is 0. You take 7 divided by 0, and you can't divide by 0 unless you're Chuck Norris. So that's not possible. So you get an undefined slope. Vertical wall, it's like stop you in your tracks. You can't have a slope at all. It's undefined. So I'm glad that example is in there. So you put this on your paper. This is undefined. Or you could say no slope. I kind of like no slope. GSP and these notes say undefined, but either one's fine. All right, let me set this last one up. All right, it says 2, 1, and 3, 3. Again, I'm concerned about this little vertical and horizontal edge triangle. The distance up here is 2, the rise is 2, the run is 1. But what kind of line is this? Is this an uphill slope or a downhill slope? Going left to right, I mean, you always read these things this way. If I'm traveling this way up the, up the x-axis, when I hit this wall, I'm going to be going up a hill. And up the hill here is going to be positive. Why is it 2? Well, rise over run here is 2. The rise and the run, rise 2, run 1, that fraction equals 2, and it's positive because it's uphill. Okay. Determine if these are we got any parallels or perpendiculars. Okay, so back to the last page, I'm supposed to look at the slopes of all these, because I'm supposed to try to find out if they're, it didn't say this on your page, but if I want to know if they're parallel or perpendicular, I got to know about the slopes. So back to this, the slopes were -1/2, undefined, and 2. -1/2, undefined, and 2. Are any of those parallel? Well, no, that's crazy talk. For them to be parallel, the slopes had to be the same. None of these are the same. They're all different. So no parallels in this page. Are there any perpendicular? Well, if they're perpendicular, I'd have to be able to take 2 of them and multiply them and get -1. Well, I can't really multiply this thing by anything because it's not a number. Remember, slope CD happened when the line was perfectly vertical. You could say that that's perfectly perpendicular to a horizontal line. That would have a slope of 0. That's also part of the definition of perpendicular slopes. But we don't have any horizontals on this page, so forget about that. But let's take a look at these. This one up here, where's my mouse? Yeah. This -1/2 and this 2, could they possibly be perpendicular? So let's look at those together. And it turns out if you take -1/2 times 2, this is the check for perpendicular, and if it turns out to be -1, then yes, I can say AB is actually perpendicular to EF. Let me see if I can get that on Sketchpad. Okay, I put those points on here the way they're, I think the names are wrong, like the A, B, C, D might be wrong, but the coordinates are right. I had -1,7 connects to this 3,5, and 2,1 connects to this 3,3. That doesn't look right. Let me check those again. It was 2,1, 3,3, and 3,5, -1,7. Let's see what that looks like. 2, 1, 3, 3. Okay, good. Then if I want to measure this angle, okay, here's the drum roll, please. Measure angle C. Whoops. C to that thing to A. If I go measure angle in Sketchpad, what's it going to tell me? Oh, look at that. It's perfectly 90 degrees. I could have known that because of these slopes. If the slopes multiply to -1, I know I'm in business. Okay, last page of examples. Find the midpoint of the segment that joins those two things. Okay, this one you could draw, but I think we're going to try without. I think we're maybe at that point. All right, so I need to find what's the halfway point between 8 and -11, and what's the halfway point between 3 and -7. This feels different to me than the slope and the distance. The slope and the distance ones, I kind of cared about rise and run and doing something with those numbers, like what's the distance from 8 to -11 and the distance 3 and -7. Here, I really care about the midpoint. What's the midpoint? What's halfway between those two? And I can find that by taking an average. There's the x average. -11 plus 8, okay, I think it's this, and that can't reduce. And the average on the other one is this, and that's -4, and that reduces this way. So that's the x-coordinate, that's the y-coordinate. On this one, okay, this is a little tricky. This one gives me the midpoint, so it's like it gives me this answer, and it is the midpoint between 0, 1, and something else. So there's this line on there somehow where there's a 0, 1 at one end. There's a midpoint of 3, 5, and I'm looking for this. What are those coordinates so that this ends up being the midpoint here? Well, this first question mark, the x question mark, has, okay, that's really hard to read, has 3 as its midpoint with 0. So in other words, if I took 0 plus that first question mark and divided it by 2, it's going to turn out to be 3. So you could probably, this isn't too bad. You could put a variable in there and solve that. That would probably be a little more responsible of me as a math teacher. Or you can maybe look at this by inspection and go, okay, what has to go up here to make this thing work out? That would have to be 6. So 0 plus, well, that had to be 6. So that first one is 6 because 0 plus 6 divided by 2 is 3. This question mark, okay, different question mark problem. 1 plus it divided by 2 is going to be 5. And so again, what's going to have to go up here is going to be 10. So this question mark is going to have to be 9. Again, I could put a y in there and solve for it, but I'm going to get 9 for that. So the coordinates here are 6 and 9 so that the averages work out to 3 and 5. 3 is halfway between 0 and 6, and 5 is halfway between 1 and 9. Okay, that's it. Of course, block B3 for me doesn't have to do the homework that's printed after this on the worksheet. This is your only homework for, wow, I guess it'll be Thursday. See you then.